Okay, everybody, welcome back, and we're going to move on to 1.2. Just to do a little recap of where we're at, we are still going to be on this first standard in our chapter, which is I can graph and identify key features. We've already done the absolute value functions. Section 1.1 is about as complicated as that's going to get. So for 1.2, we're going to move on to the piecewise functions. 1.2 piecewise functions. So first of all, a piecewise function is a function. A function defined by two or more equations. So what we mean by that, I've given you an example down here. We have this f of x, and this time f of x equals, and we've got these little bracket type things, and we've got two separate equations. So if x is less than or equal to 0, so we would go look at our graph, x is 0 right there on the y-axis. If x is less than or equal to 0, then we're going to use this function, which is x minus 2, which is a line, and it looks like this. So that's our equation, x minus 2, and that's graphed. But if x is greater than 0, then we're going to use this other function, which is 2x plus 1, which is graphed over here. Notice that the first function stays on the left of 0, the second function stays on the right of 0, so your ultimate function looks like this, and it's made up of two different pieces. The other thing before we move on that I want to point out is, do we notice that this function on the left has a closed dot when it meets the y-axis versus this function over here has an open dot when it meets the y-axis? Two different reasons for that. The first reason is because this one says equal to. So when it gets to 0, it's equal to, so we're going to close in the dot. This one does not say equal to, so when it gets to the axis, we're going to open the dot. The second reason that this would need to happen is because of the definition of a function. If you guys remember very briefly your vertical line test, if you take your pencil and you lay it vertically, at any given moment you can only touch one point on the graph. If you were to have a graph that would look like this, and you did your vertical line test right here, you would be touching two parts of the graph, and that would not be a function. So right here, when I do my vertical line test, this dot is closed, this dot is open, so I'm only touching one part of my graph, so this is still a function. If they were both closed, then we would have a problem. Okay, so example 1, evaluate each function for the given values. So we've got our piecewise function. I believe this is actually the function we were just dealing with as our example. And I want to know, well, what does the function actually equal when x equals 5? So what we need to figure out is, okay, well, I'm going to take 5 and I'm going to substitute it into the function. But should I substitute it up here or should I substitute it down here? Well, that's going to be answered over here. So if x equals 5, is 5 less than 0? Or is 5 greater than 0? And 5 is greater than 0, so we're going to substitute 5 into 2x plus 1. So we're going to have 2 times 5 plus 1, which is 10 plus 1 is 11, so the function value at 5 is 11. If we take a look at the next one, well, what's the function value when x equals negative 3? So is negative 3 less than or equal to 0? Or is negative 3 greater than 0? The answer to that is less than 0, so we're going to substitute it in this function. So negative 3 minus 2 is negative 5. Now, if I go back on our graph, we should be able to see this. So when x is negative 3, because we have it graphed here, so x is negative 1, negative 2, negative 3, I would go down here and look at that. The y value is negative 5. That's what you just found. I couldn't really do that with our first one because it went off the graph, but it would be up here somewhere. X equals 0. Okay, so x equals 0. Is that at x is less than or equal to 0? Or is that x is greater than 0? X equals 0 is 0, so we're going to substitute it into the top one. So 0 minus 2 is negative 2. And again, if we go back and look at our graph at x equals 0, we would be down here at the closed dot at negative 2. We wouldn't be up here because that's an open dot, which means we're not really there. Letter B, we have a new piecewise function. This function is actually defined by 3 different functions, and I want all of these. So number 1, f of negative 8. Okay, well, f of negative 8, that's telling you x equals negative 8. Is negative 8 less than negative 2? Is negative 8 between negative 2 and 5? Or is negative 8 greater than 5? Negative 8 is less than negative 2, so we're going to substitute it into this function. Well, there's no x here. Where do I put it? Well, this is a constant function. This function is always 3. So whether f is negative 8, negative 10, negative 100, this will still be 3. So the answer, or the function value, is just 3. F of 0. So 0, is that less than negative 2? Is it between negative 2 and 5? Is it greater than 5? It's right here. 0 is between negative 2 and 5, so we're going to substitute 0 into this function. So 0 plus 2 is 2. Our number 5, and I realize I went down the page, not across the page, f of 5. So is 5 less than negative 2? Is it between negative 2 and 5, or is it greater than 5? And the key here is the equal to sign. So it is less than or equal to 5, so we're going to substitute it here. So 5 plus 2 is 7. Okay, next one, f of negative 2. Where would that be? It would be right here because it is greater than or equal to negative 2. So we're once again going to substitute right there. So negative 2 plus 2, our function value is 0. F of 3. 3 would also lie in between negative 2 and 5, so we're going to substitute in here again. So 3 plus 2 is 5. And then f of 10. Where would f of 10 lie? So 10 is greater than 5, so we would substitute 10 into this function. So 4 times 10, and our function value is 40.